Hello everyone. Now the third kind of reaction is displacement reaction. Displacement reaction, as the name suggests, displacing. Displacing means something is going to displace another component from its position and taking its place. So in the case of reactions of such type, we generally take a solution containing a metal, and these solutions which contains a metal, when they are combined with another metal which is more reactive than the metal present in the solution, then more reactive metal displaces the less reactive metal from its own solution and make new products. So such a kind of reactions in which a more reactive metal, that is a single element, when it displaces a less reactive metal in from its own solution, then we consider it as displacement reaction. Now before proceeding further, we should understand a very important term called as reactivity series. In nature, variety of elements are there, in which which are mostly solid, we consider them as metals. So the metals have a particular nature. They have their own reactivities. Some of them they react very spontaneously, while others they react comparatively slowly. So when these metals are arranged in a particular series, as you can see on the screen, these metals, when they are arranged in a particular series in a particular decreasing order of their reactivities, as we go from top to bottom in the series, that is showing the decreasing order of their reactivities. That means the most reactive will be at the top and the least reactive will be at the bottom. So such a kind of series in which the metals are arranged in decreasing order of their reactivities or increasing order of their reactivities, such a series is called as reactivity series. Now, in this series, as you can see, potassium, barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead. Then it is followed by hydrogen, copper, mercury, silver, platinum, and gold. So, in this order, when we arrange these metals, we find that the potassium is at the top and is considered as the most reactive metal, while the gold at the bottom is considered as the least reactive metal. Now one question arises that about the presence of hydrogen. Normally hydrogen is a non-metal, but here in the list of metals we have kept it because it shows the basic nature of metals, that is it can form a cation. So since it can form a cation like that of other metals, it has been kept in this series. Now if I have made a block around the hydrogen, it also suggests us that all those metals which are placed above the hydrogen, they are more reactive than the hydrogen, and all those metals which are kept below the hydrogen are less reactive than hydrogen. So any metal from the above list can be able to displace the hydrogen from its salt solution. Similarly, any metal which is below the list, below the hydrogen, cannot displace hydrogen from its salt solution, because hydrogen is considered now more reactive than copper, mercury, silver, platinum, and gold. Now move on to the examples. I have also shown a list of non-metals also, like halogens, fluorine, chlorine, bromine, and iodine. They are also arranged in the decreasing order, that fluorine can displace the chlorine from its salt solution, or chlorine can displace bromine from its salt solution, and so on. So let's take an example, a very common and familiar example of displacement reaction, which you have already studied in class 7th, where the iron metal is going to be reacted with copper. Now copper salt solution is taken as copper sulfate. So when iron metal combines, is kept in the blue colored copper sulfate solution, it shows a displacement, and the displacement will be highlighted by the change in color of the blue colored copper sulfate solution to green colored iron sulfate solution. So the green color of the solution comes because of the displacement shown by iron, which has displaced copper from the salt solution and taken its place, and the blue color changes to green. And on that iron nail, we find a deposition of the displaced metal, that is copper, as a brown coating. So this is a very common example of displacement reaction. Similarly, as I told you that all the metals above the hydrogen can displace hydrogen from its salt solution. So here we have a salt solution of hydrogen in the form of sulfuric acid. When zinc, which is placed above hydrogen in the reactivity series, is combined with sulfuric acid, then it displaces hydrogen from the salt solution, takes its place, and hydrogen gas is released out. Same with, if we select lead from the series and combine it with salt solution of copper, then again the lead, being more reactive, displaces the copper from copper chloride and forms the lead chloride along with copper metal. So this is how we understand the displacement reactions. Thank you.